Hello, Pre-Calculus. Here is your video lesson for today. We have the trig form of a complex number. Just as real numbers can be represented by points on the real number line, you can represent a complex number, z equals a plus bi, as the point a comma b in the coordinate complex plane. The horizontal axis, side to side, your x-coordinates, that's the real part, the real axis. Vertical axis is going to be your imaginary axis. Okay, so you can kind of see here in the notes, they have 3 plus I, that's 3 comma 1, 3 to the right and 1 up. Your other one here is negative 2 minus I, 2 to the left and 1 down. So basically the I part just becomes your y coordinate. The absolute value of the complex number a plus bi is defined as the distance between the origin and your point. So then it just becomes, because we're using the origin 0, 0, it's pretty easy to do. The square root of a squared plus b squared. Okay, because you're just making a triangle from the origin, so it's just a squared plus b squared equals c squared. So the square root of a squared plus b squared. All right, so go ahead and push pause here with number 1 and see if you can sketch a quick, plot a quick sketch here of where this dot would be and come up with the absolute value. Go ahead and push pause at this time. Okay, welcome back. We got negative 2 plus 5i, so that's going to be the same as negative 2 comma 5. So we're over here somewhere. Oop, not that far probably. Negative 2, 5, probably closer to there. Okay, its absolute value, square root, negative 2 squared plus 5 squared. So we got the square root of 29, and we cannot reduce that, and we'll leave it there. We have learned how to add, subtract, multiply, and divide complex numbers. To work effectively with powers and roots of complex numbers, it's often helpful to write them, the complex numbers, in trig form. Consider the non-zero complex number a plus bi by letting theta be the angle from the positive real axis, measured counterclockwise, to the line segment connecting the origin and the point AB. We can write a equals r times cosine theta, and b equals r times sine theta, where r is your absolute value or your distance that we just did there. And by doing that, we have the complex form, or the trigonometric form of your complex number, where a plus bi, your a part, is r times cosine theta, plus bi, your imaginary part, your up and down part, is r times sine of theta with the I behind it. Sounds complicated. It's a bit of kind of like bending your brain a little bit, but once you wrap your mind around it, it's not too bad. It's not too bad. Okay. Trig form of a complex number, z equals a plus bi, is z equals r times cosine theta plus I sine theta. The number r is your modulus of z, and theta is called the argument of z. I also kind of think of r as like the radius. It's how far out you are. Modulus is going to be a little more fancy there for you. The trigonometric form of a complex number is also called the polar form, and we're going to continue working with these. Because there are infinitely many choices for theta, the trigonometric form of a complex number is not unique. Normally, theta is restricted to the interval 0 to 2 pi, although on occasion it is convenient to use negative pi's. All right, here we go. Write the complex number z equals negative 2 minus 2 radical 3i in trig form. Okay, step 1, we got to come up with our r. square root of the first part, the real part, negative 2 squared, plus your imaginary part squared, negative 2 radical 3 squared. Okay. Negative 2 squared is 4. Negative 2 squared is 4. Radical 3 squared is 3. 4 times 3, that's about 12. So we have the square root of 16. Our R value here is 4. Okay, the next thing we need is our angle. Okay, tangent works out well for this because tangent theta equals sine over cosine, or your vertical over your horizontal. So we're going to do tan inverse of negative 2 radical 3 over negative 2. And you're probably going to have to use some parentheses here when we're typing this in. Oh, calculator's back here. Okay, second tan. We're going to go another set of parentheses just to be safe. Negative 2 radical 3 divided by negative 2. I might have overdone the parentheses there, but all right, so 60 degrees, but we're in theta, we're in radians. I could switch this to radian mode here, math mode radians. Oh, it doesn't leave it in pi form though for me, so it is kind of nice to have it in degrees, I guess, because then you could switch that to pi to radians a lot nicer. So 60 degrees. Okay, and I know that is pi over 3. Now, we've got to be careful here. Negative 2 radical 3, so this way and this way. This is telling me pi over 3 up here. Okay, that's because our tan inverse is only defined right there. So now it's giving me this as the reference angle, pi over 3, and now I've got to use my brain that I should be in quadrant 3. How do I get it there? That's just straight across. That's 1 pi, 2 pi, 3 pi. That's going to be 4 pi over 3. Got to make the correction, put it in the right spot, put it in the right quadrant. 4 pi over 3 to make sure we're in quadrant 3 to match our coordinate. Okay, so we got all the pieces we need. We got the R, or our modulus, and we have our theta, or the argument, and we're ready to write it. 4, big parentheses, cosine 4 pi over 3 plus I sine 4 pi over 3. You did it. You did it. Piece of cake. Okay, now go the other way. Take the complex number in trig form to standard form. Okay, go the other way. So we have 8 times cosine of 2 pi over 3 plus I sine 2 pi over 3. All right, 2 pi over 3 is on your unit circle, so I would expect you to be able to do this without the calculator. Some of these might not be on the unit circle, so then you wouldn't be able to do that necessarily quite as easily. 2 pi over 3 for our cosine. You can do a quick little sketch. 1 pi over 3, 2 pi over 3. So we're going to be at negative a half comma radical 3 over 2. Okay, so we're going to have negative 4 there. 4 times radical 3 over 2. The 4 over 2 is, or 8 over 2 is going to be 4. So we'll have 4i radical 3. 8 times negative a half, negative 4. 8 times radical 3 over 2. Just reduce the 8 over 2 for a 4. 4i radical 3. Okay. This works out well for multiplying and dividing. There's a lot of mumbo-jumbo going on right here. You can read through it if you want. It's a lot easier than that. Okay, when you multiply them, you multiply the R numbers and you add the thetas. And when you divide them, you divide the R numbers and subtract the thetas. Pretty easy stuff. That's down here in there. It might not be quite as easy in plain old English as that. Okay, multiply those two numbers. Okay, so when we multiply, 2 times cosine 2 pi over 3 plus I sine 2 pi over 3 times 8 parentheses cosine 11 pi over 6 plus I sine 11 pi over 6. Okay, we multiply the outsides, 2 times 8, and then we add the thetas. Cosine of 2 pi over 3 plus 11 pi over 6. Ooh, those are not good. I did not write those well. Plus I sine 2 pi over 3 plus 11 pi over 6. Okay, next we need to add those fractions. 2 pi over 3 and 11 pi over 6. 2 pi over 3 would be the same as 4 pi over 6. 4 pi over 6 and 11 pi over 6 is 15 pi over 6. Reduce, divide those all by 3, that's 5 pi over 2. Where is 5 pi over 2? 1, 2, 3, 4, 5 pi over 2. We're at 0, 1. So this is going to be 16 in the front. Cosine of 5 pi over 2 is 0. Sine of 5 pi over 2 is 1. 1i, there's the I there, plus 1i. Okay, 16 times 0 is 0. 16i is just going to be 16i. Same deal here with division. All right, you divide, and I don't like what they did here with this one. We'll throw some numbers on in front because they didn't even give us a number in front. Okay, they didn't even give us a number in front. So we'll say this was a 8 in the front, and we'll say this was a 2 in the front of this one. Just copying these basically here. Okay, we're going to say that there was a 2 in front of this one. So it's 8 cosine 40 degrees plus I sine 40 degrees times 2 times cosine 10 plus I sine, or divide by, 2 cosine 10 I sine 10. So we're dividing. You divide the fronts, subtract the degrees. So we got 8 over 2 cosine of 40 minus 10 plus I sine 40 minus 10. 4 cosine 30 plus I sine 30. Okay, cosine of 30, if you want to draw a quick sketch, the horizontal part's the longest there, that's 4 times, this is going to be radical 3 over 2, plus I times sine of 30 is a half. And if I multiply those by 4, this will be 4 radical 3 over 2, which is just 2 radical 3. 4 times a half I is just going to be plus 2I. Okay, that's as far as we're going to get. About 15 minutes there, that's about as far as we're going to get, and we'll hit the rest of those on Monday, the rest of the lesson there on our complex numbers in trig form. Okay, feel free to read through the book and pick up some extra stuff, and we'll see you on Monday.